Hello, math friends. Welcome back to our channel, where we believe that math isn't just numbers on a page, it's a skill for life, and it's for everyone. In our last episode, we discovered why mental math matters. It makes us quicker thinkers, better problem solvers, and more confident learners in real life situations. But let me ask you this: if you were building a house, would you start with the roof? Of course not. You'd need a solid foundation first. And in the same way, before children can master mental addition, they need to build certain foundational skills. Think of it as preparing the soil before planting seeds. Seedling without healthy soil, the seeds won't grow strong. Without the right math foundations, mental addition can feel confusing or frustrating. That's why today's lesson is so important. We'll talk about the prerequisite skills every child needs before learning mental addition. And don't worry, it's not about memorizing rules. These are fun, hands-on activities that prepare the mind, sharpen the senses, and make math meaningful. Here's the best part: these strategies are for all learners. Whether your child is sighted, low vision, or blind, every single one can thrive in math when learning is made accessible and engaging. So, teachers, parents, support systems, and learners, stay tuned. By the end of this video, you'll have practical tools you can start using right away to build a strong foundation for success in mental math. Hello, math friends. Welcome back to our channel, where we believe that math isn't just numbers on a page, it's a skill for life, and it's for everyone. In our last episode, we discovered why mental math matters. It makes us quicker thinkers, better problem solvers, and more confident learners in real life situations. But let me ask you this: if you were building a house, would you start with the roof? Of course not. You'd need a solid foundation first. And in the same way, before children can master mental addition, they need to build certain foundational skills. Think of it as preparing the soil before planting seeds. Seedling without healthy soil, the seeds won't grow strong. Without the right math foundations, mental addition can feel confusing or frustrating. That's why today's lesson is so important. We'll talk about the prerequisite skills every child needs before learning mental addition. And don't worry, it's not about memorizing rules. These are fun, hands-on activities that prepare the mind, sharpen the senses, and make math meaningful. Here's the best part: these strategies are for all learners. Whether your child is sighted, low vision, or blind, every single one can thrive in math when learning is made accessible and engaging. So, teachers, parents, support systems, and learners, stay tuned. By the end of this video, you'll have practical tools you can start using right away to build a strong foundation for success in mental math. Here's a big question: why not just jump straight into teaching addition? Because mental math is so much more than memorizing number facts. It's about understanding how numbers work. Children need to first develop number sense, knowing what numbers mean, how they relate to each other, and how they can be grouped or broken apart. They also need to practice sequencing, what comes before and after, and build logic to make sense of patterns. Think of it like learning to ride a bike. You don't start with racing, you begin with balance and practice. Without these foundations, addition can feel stressful and confusing. But with them, it becomes exciting, natural, and even fun. And the best part? These prerequisite skills are universal. Whether a learner is sighted, blind, has low vision, or learns in a different way, these skills create a pathway for every child to succeed in mental math. Our big goal is simple but powerful. We want learners to solve problems in their heads with ease. Picture this: a child at the store quickly checks if they have enough coins to buy a snack, or a student instantly figures out how many chairs are left after some classmates sit down. These are everyday situations, and mental math helps children handle them confidently. This confidence goes beyond numbers, it gives learners a sense of independence. And when children succeed at small math challenges every day, something amazing happens: they stop fearing math and start to enjoy it. And remember, this goal isn't just for sighted learners, it's for every child, including those who are blind or have low vision. Math is practical, universal, and something everyone can grow to love. The first foundation is number recognition. Before children can add, they must first know what numbers are and what they represent. For sighted learners, this could mean using flashcards, colorful number charts, or fun digital games. For learners who are blind or have low vision, we can use tactile numbers, like numbers cut from cardboard, wooden pieces, raised dots, or braille cards. Here's a quick example. If I show the number 5, a sighted child might recognize the symbol and say, "That's 5." But we don't stop there. They also need to connect it to 5 things: 5 apples, 5 toys, or 5 claps. For visually impaired learners, they can feel 5 buttons, 5 beads, or even tap the table 5 times. This way, numbers become more than just marks on a page or dots under the fingers. They become real, meaningful quantities. And when children make this connection, they build the strong foundation needed for mental addition. Without number recognition, adding numbers is just guesswork. Once children can recognize numbers, the next step is counting, and counting is so much more than memorizing a number list. It helps children build rhythm, sequence, and order, which are the backbone of mental addition. We always begin with forward counting, 1, 2, 3, and so on. But just as important is backward counting, 10, 9, 8. This prepares their minds for subtraction later on. Then comes skip counting, by 2s, 5s, or 10s. Why do we do this? Because skip counting is actually the early stage of multiplication. It also makes addition much faster and more flexible later. Now, here's the fun part: counting should never feel like a drill. Use songs, clapping, jumping, or marching to bring energy into it. For example, when counting by 2s, the class can clap twice for each step: 2, 4, 6, 8, and for learners who are blind or have low vision, we use real objects: beans, coins, bottle caps, or beads. They can feel and move each item as they count, making numbers tangible and meaningful. When counting is playful, physical, and hands-on, children don't just say the numbers, they own them. And that's the kind of confidence they need for mental addition. The next foundation is understanding quantity through one-to-one correspondence. This simply means that each object is counted once. For example, when a child counts 3 apples, they don't just say the numbers out loud, they point to each apple as they say, 1, 2, 3. That way, they learn that the number 3 represents exactly 3 things. For learners who are blind or have low vision, this becomes even more hands-on. We use tactile counters, like buttons, beans, coins, or pebbles. As they touch each one, they say the number out loud: 1, 2, 3. This step is so important because it connects the abstract idea of numbers to the real, concrete world. Without this connection, numbers remain just words or symbols. But once children master one-to-one correspondence, they begin to see numbers as meaningful quantities they can work with, and that's a huge step toward mental addition. After children learn to count and recognize numbers, the next step is comparing numbers. We start by asking simple questions: which group has more? Which has less? Are they the same? For example, if 2 children hold candies, one may have 3 and the other 5. The child with 5 has more, and the one with 3 has less. Once children understand the idea of more and less, we can introduce the symbols. These symbols give children a language to describe what they already notice in everyday life. For sighted learners, we can show this with pictures, objects, or even fun games. Who has more toys? For learners who are blind or have low vision, we use tactile counters, like 2 groups of beans or buttons. They can feel each group and compare: which pile is bigger? Which one is smaller? This skill is key because mental addition is not just about putting numbers together. It's also about understanding relationships between numbers. Comparing numbers helps children think critically, and it makes math more real and exciting. Now let's talk about a very special number, 0. 0 is often overlooked, but it's absolutely essential for understanding math. 0 simply means nothing left. Here's an example. If you had 5 cookies and ate them all, what do you have now? An empty plate. That's 0 cookies. Cookie, for learners who are blind or have low vision, you can make it concrete. Let them hold 3 buttons, then take them away one by one. What's left in their hand? Nothing, that's 0. For auditory learners, try this. Clap 3 times, clap, 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 then stop. That's silence? That's 0. Once children understand 0, they begin to see how numbers can grow when we add, and shrink when we subtract. 0 becomes the anchor point that makes addition and subtraction much clearer and more meaningful. The next important foundation is the part-whole concept, sometimes called number bonds. This means children learn that a number can be split into smaller parts. For example, the number 5 can be made of 2 and 3 or 4 and 1. Why is this powerful? Because it helps the brain see numbers in flexible ways. Instead of memorizing every single math fact, children learn strategies. For example, if they know that 5 is made of 2 and 3, then solving 2 plus 3 becomes instant and natural. For sighted learners, we can show this with diagrams like circles or bars, or by grouping objects. 5 apples can be separated into 2 and 3, or 4 and 1. For learners who are blind or have low vision, we can use tactile counters, like beans, buttons, or coins, and physically split them into groups. Number bonds are the bridge between knowing numbers and working with numbers. Once children understand that numbers can be broken apart and put back together, mental addition becomes much easier and even fun. The next foundation is understanding successor and predecessor. In other words, the number that comes right after and the number that comes right before. For example, what comes after 4? The answer is 5. What comes before 7? The answer is 6. This simple practice helps children move smoothly along the number line, which is exactly what they'll need for mental addition. After all, adding often means counting on to the next number, and subtracting means counting back. For sighted learners, a number chart or number line works great. For learners who are blind or have low vision, we can make this physical, like walking along a line of tiles on the floor, stepping forward for the successor and backward for the predecessor. By practicing before and after, children become flexible with numbers, and that flexibility is what makes mental addition quicker, easier, and more natural. The next foundation skill is place value awareness, understanding ones and tens. Children need to see and feel that 10 ones make 1 10. For example, 10 loose straws can be tied into one bundle. That bundle represents a 10, while the leftover single straws are ones. Why is this so important? Because it prepares children for addition with carrying, also called regrouping. If they already understand that 13 is really 1 10 and 3 ones, then problems like 9 4 make more sense. They can regroup 10 ones into 1 10 and 3 ones. For sighted learners, we can use visual aids like number blocks, beads, or straws. For learners who are blind or have low vision, we can use tactile materials, buttons grouped into tens, rubber banded sticks, or even beans in small bags. When children grasp place value, they stop thinking of numbers as just symbols on a page. Instead, numbers become organized groups they can work with, and that makes mental addition far easier. The next foundation skill is place value awareness, understanding ones and tens. Children need to see and feel that 10 ones make 1 10. For example, 10 loose straws can be tied into one bundle. That bundle represents a 10, while the leftover single straws are ones. Why is this so important? Because it prepares children for addition with carrying, also called regrouping. If they already understand that 13 is really 1 10 and 3 ones, then problems like 9 4 make more sense. They can regroup 10 ones into 1 10 and 3 ones. For sighted learners, we can use visual aids like number blocks, beads, or straws. For learners who are blind or have low vision, we can use tactile materials, buttons grouped into tens, rubber banded sticks, or even beans in small bags. When children grasp place value, they stop thinking of numbers as just symbols on a page. Instead, numbers become organized groups they can work with, and that makes mental addition far easier. The last but very important foundation is the language of math. Children must understand the words that signal addition. Words like add, plus, more, together, sum, these aren't just vocabulary, they're clues that guide what to do with numbers. We can teach this using everyday examples. Say, you have 2 cookies, and I give you 1 more. How many do you have now? When children answer, they're not just adding numbers, they're learning the math language that explains real-life situations. For sighted learners, we can use colorful posters with math words, or word cards during lessons. For learners who are blind or visually impaired, we can use spoken math stories and real objects, like actually handing them cookies, buttons, or coins to act out the story. When children understand the language of math, they can connect what they see and feel in daily life to what they'll solve later on paper. And that's how they build confidence for mental addition. Before jumping into addition, learners need readiness activities that sharpen their thinking skills. First is sorting and classifying. Children can group objects by color, shape, or size, like putting all the red blocks together or separating big spoons from small spoons. This builds logical thinking. Next is pattern recognition. Patterns are everywhere: red, blue, or clap, clap, stomp. Recognizing patterns trains the brain to predict and see order, which is important in skip counting and sequences. Finally, we practice problem solving in daily routines. For example, setting the table, 1 plate, 1 spoon, 1 fork for each person. Or sharing snacks. We have 6 cookies and 3 friends. How do we share them equally? These small, real-life challenges make math meaningful and practical. Whether learners are sighted or visually impaired, readiness activities prepare their minds to see math not just as numbers on paper, but as tools for everyday life. Math doesn't only happen in the classroom, it lives in our daily routines. In fact, the best math lessons are often hidden in everyday experiences. You can count snacks at the table. How many cookies do you have? How many do I have? Who has more? Or count toys while cleaning up. Let's see how many cars are on the shelf. Even counting steps on the way to the park makes numbers come alive. For children who are blind or have low vision, tactile items like coins, spoons, or bottle caps work beautifully. They can touch each one as they count, making numbers concrete and real. When math is tied to real life, it stops being abstract. It becomes personal, fun, and meaningful, exactly the kind of foundation that makes mental addition natural and exciting. When children can recognize numbers, count forward and backward, understand quantity, compare groups, recognize zero, and break numbers into parts, they're ready for mental addition. These aren't random skills. Each one is like a puzzle piece, and when the pieces fit together, the bigger picture of math becomes clear. Without these foundations, mental addition can feel confusing and frustrating. But with them, it feels natural, exciting, and even fun. That's the power of building strong number foundations. Every learner, whether sighted or visually impaired, can move forward with confidence in math. So, how do we bridge from these foundational skills into mental addition? We move step by step. First, start with concrete objects, like apples, toys, or counters that learners can see or touch. Next, move into tactile and auditory learning, clapping, tapping, or footsteps. These keep math active and multisensory, which is especially helpful for children who are blind or have low vision. Finally, shift to mental visualization, encouraging learners to imagine the numbers in their heads. This gradual progression, from concrete to tactile and auditory to mental, respects each learner's pace and learning style. It makes the transition smooth, natural, and inclusive for all. Now that we've built the foundation, we're ready to take the next big step, mental addition. In our next vlog, we'll learn how to add numbers in our heads, quickly, confidently, and in ways that are fun for everyone. Whether you're sighted, blind, or have low vision, these strategies are designed to include and empower every learner. So stay tuned, and don't forget to like, share, and subscribe if you want more tips and activities that make math practical, fun, and inclusive. See you in the next episode, where we turn strong foundations into real mental math skills.